Okay, this is the last video on logs and exponents and taking derivatives. Sometimes you're dealing with a function that's weird like this, x raised to the x. It's not a power function, it's not an exponential function. In fact, it looks a little bit, and when I say a little bit, I mean a lot. Looks like this. I don't know if you can see that. When x is 1, 1 raised to the first is 1, 2 squared is 4, 3 cubed is 27, 4 to the fourth is 256 or something like that. It grows very, very fast. It's a very fast-moving function. So we want to know how fast is it moving? What's the rate of change? Okay, well, I don't know how to take this derivative. It's not a power function, so we can't pull the power out front and subtract 1. It's not exponential, so we're going to have to take the log. By doing this, this allows us to bring the x out front. And now we have a product on the right side. So on the left side, it's 1 over y times y prime equals first times the derivative of the second plus the second times the derivative of the first, which is just 1. So we have 1 over y prime equals 1 plus natural log of x. And so y originally was x to the x, so your function is changing at a rate of x to the x over or times 1 plus natural log of x. So the only time this thing is not changing is when the derivative is 0, has a slope of 0, and that occurs when natural log of x equals -1, and that's going to be at e to the -1. So there you go. Here's another example coming up. Alright, the last example in this video is x raised to the sine x. Okay, just very similar. It has an x as a base, has an x and a power. It's going to be something that just kind of bounces back and forth and up and down and back, and gets bigger and taller every single time that x gets bigger. So we take the derivative. First, we're going to have to take the natural log, because we need that sign to get out of the power. So you got natural log of y equals sine x times natural log of x. Okay, we're going to use the chain rule over here with implicit differentiation. 1 over y times y prime equals first times the derivative of the second plus the second times the derivative of the first. So we're left with y prime equals x sine x times sine x over x plus cosine x natural log of x. And that's it. I mean, it would be very difficult to find the zeros of this function. Where is it equal to 0? But I'm not going to worry about that today.